Suppose Q is a solid region bounded by the plane x plus 2y plus 3z equals 6 and the coordinate planes with density rho of x, y, z equal to x times y squared times z. Find the center of mass. The most important thing we need to notice is what the boundaries are going to be in each of these directions, in the z direction, the y direction, and the x direction. Now, if we notice, because we are bounded by the coordinate planes and this plane, the lower bound is going to be 0 for all of these. So z is bounded from 0 to some function, y will be bounded from 0 to some function, and x will be bounded actually between two constants. So first I'm going to solve this plane. Z equals, that will be 1/3, open parentheses, 6 minus x minus 2y. And then if we restrict, so that's our boundary action on the z, in the z direction. Now, if we restrict ourselves into the xy plane, this now just becomes x plus 2y equals 6, that line. And so we can solve that for y to find the boundary of y. And that would be 1/2, open parentheses, 6 minus x, close parentheses. Now these are relationships, so I'm actually going to, just to describe this function, I want to just redefine these, so I don't have to rewrite these over and over again. So I'm going to say w is the function 1/3, parentheses 6 minus x minus 2y, and I'll use v for my 1/2, parentheses 6 minus x, close parentheses. So when I set up my integration, I'm going to use these variables to represent those quantities, just so I don't have to rewrite that function over and over again. Now, in finding mass, that would be equal to the integral from, oh, I didn't find my x values. Well, jumping back over here, if we restrict ourselves only onto the x-axis, that means the y and z are both 0, then we find that x goes from 0 to 6. So the mass will be the integral from 0 to 6 with respect to x of the integral from 0 to y. Well, I'm going to call that v, 0 to v with respect to y, of the integral from 0 to w with respect to z, thinking about my boundaries, how I've defined those, and that's of the function x, y cubed, or y squared, x, y squared, z. That's our function. Now, there's a lot of algebra I'm going to skip as we go through here because these are things we should be able to do. So the next step here will be equal to, once we find the antiderivative with respect to z and evaluate our endpoints, this becomes the integral from 0 to 6 with respect to x of the integral from 0 to v with respect to y of the function 1/18 multiplied by x y squared, open parentheses, 6 minus x minus 2y, close parentheses, squared. Now, finding the antiderivative of that function, the integral, with respect to y, and evaluating that as well, this becomes the integral from 0 to 6 with respect to x of the function negative x to the 6th divided by 4,320 end fraction plus x to the 5th over 144 end fraction minus 1/12 x to the 4th plus 1/2 times x cubed minus 3/2 times x squared plus 9/5 times x. And when we find that integral, that will be 54/35. Now we need that value as the mass for each of the moments, or to find the center of mass once we find the moments, that is. All right, so just scroll down a bit. And the moment in the xy plane, mxy, will be equal to all those same boundaries. The integral from 0 to 6 with respect to x of the integral from 0 to v with respect to y of the integral from 0 to w with respect to z of the function z times x squared, or back up, my function is in fact z x y squared z. All right, now finding our antiderivative of the innermost, or with the innermost integral. This becomes the integral from 0 to 6 with respect to x of the integral from 0 to v with respect to y of the function negative 1 over 81 end fraction x y squared open parentheses x plus 2y minus 6 close parentheses cubed. Now finding the antiderivative of that function and evaluating, we find the integral from 0 to 6 with respect to x of fraction x to the 7th with the denominator of 38,880 end fraction minus x to the 6th over 1,080 end fraction plus x to the 5th over 72 end fraction minus x to the 4th over 9 end fraction plus x cubed over 2 end fraction minus 6x squared denominator of 5 end fraction plus 6x over 5. And if we evaluate that integral, that will be 27 over 35. There's mx, or mxy. Now we have 2 more moments to find. That will be mxz, which is the moment in the xz plane. That will be the integral from 0 to 6 with respect to x of the integral from 0 to v with respect to y of the integral from 0 to w with respect to z of the function y times x y squared times z. And following a lot of those same steps, we find this is the integral from 0 to 6 with respect to x of the integral from 0 to v with respect to y of the function 1 over 18 end fraction x y cubed open parentheses x plus 2y minus 6 close parentheses squared, which would then be equal to the integral from 0 to 6 with respect to x of the function x to the 7th over 17,280 end fraction minus x to the 6th over 480 end fraction plus x to the 5th numerator, or was a numerator denominator of 32 minus x to the 4th power with a denominator of 4 plus numerator 9x cubed denominator of 8 end fraction minus 27x squared as a numerator with a denominator of 10 end fraction plus 27x as a numerator with a 10 as a denominator. That's all with respect to x. Now we can find that value. That turns out to be 243 over 140. Finally, we can find myz, the moment in the yz plane. That will be equal to the integral from 0 to 6 with respect to x of the integral from 0 to v with respect to y of the integral from 0 to w with respect to z of the function x times xy squared z. Our inner integral becomes, or evaluating the inner integral, this becomes the integral from 0 to 6 with respect to x, of the integral from 0 to v with respect to y, of the function 1 over 18 end fraction x squared y squared, open parentheses, x plus 2y minus 6, close parentheses, squared. Evaluating the next integral, this becomes the integral from 0 to 6 with respect to x of negative x to the 7th, that's over 4,320, end fraction, plus x to the 6th over 144, minus, or end fraction, minus x to the 5th over 12, end fraction, plus x to the 4th over 2, end fraction, minus 3x cubed over 2, end fraction, plus 9x squared over 5, end fraction, and we can find that value to be 81 over 35. Each of these steps is a calculus 1 step, but of course we're doing it with several variables. That's where the skipping some of the algebra and things comes in. A lot of this can turn out to be a bunch of power rules. Okay, now we know that the center of mass, parentheses, x bar, comma, y bar, comma, z bar, is equal to the ordered, or the point, the ordered triple, which is a point, and it's mx, or myz over the mass m, comma, mxz over the mass m, comma, mxy over the mass m. So dividing each of those values that we've already found, the center of mass is the point 3/2, comma, 9/8, comma, 1/2.